Hello and welcome to today's class. So without the use of the calculator, how do we evaluate this? So we take our solution. All right. Now we're going to apply the Euler formula. Okay. So we all know the Euler identity or the Euler formula. So if we apply it to this part of this equation and to this part, we're going to come up with a special equation. So from Euler equation or formula, so let's take care of applying. So have here applying the Euler's formula. So we're going to have our I plus the square root of 3 iota, which is the numerator here. This is going to give us our 2 times e raised to the power of iota there times our pi all over 3. And the denominator, which is our 1 minus the square root of 3 iota, if we equally apply that, then we're going to have our 2 the times our e all raised to minus I the pi all over 3. Okay, now if you want me to make a video on a detail on how to simplify this or applying the Euler equation to get this expression from this given expression here, then drop it in the comment section and I will not hesitate to do a video or to make a video on that. So if we have this to be this and this to be this, then we can put the whole of this into this equation. And so this is going to give us our bracket open 1 plus the square root of 3 all over 1 minus the square root of 3 iota, please. The iota all raised to the power of 10. This is equal to our bracket open. The first one we have 2 times our e all raised to iota pi all over 3. Then all over our 2 times e raised to minus iota pi all over 3 close bracket all raised to power 10. Now with what we have here, you discover that these 2 and this will leave. We are having e here, we are having e here as the base number, and so we can apply the law of indices, which says that if you have your a all raised to the power of m all over a raised to the power of minus n, this is equal to your a to the power of m, then minus bracket minus n close bracket. Then if we add up, this is going to give us our a to the power of m plus n. So if we apply this law, then we can move this power up here. So if we do that, this is going to give us, this now implies that our e all raised to the power of iota pi all over 3, then minus bracket minus our iota pi all over 3 close bracket. And so if we simplify, this is going to give us e to the power of our iota pi all over 3, the plus iota pi all over 3. So we can add these two together. If we do this, this is going to give us our e to the power of our 2 iota pi all over 3. Okay, mind you, we are having everything here raised to power 10. Let's include this raised to power 10 and this also raised to power 10. Then this raised to power 10 also. So we can use this to multiply this. So if we multiply out, this is going to give us our e all raised to the power of 20 iota pi all over our 3. So what does that imply? It means that our original expression, which is 1 plus the square root of 3i all over 1 minus the square root of 3i all raised to the power of 10, this is equal to our e to the power of 20 iota pi all over 3. Okay, now look at this expression we have here. If we evaluate it, if we simplify this expression, applying the Euler equation again, okay, You know, our Euler equation says that your e to the power of your iota theta is equal to the cosine of theta there plus the I sine our theta. If we apply this to this expression, we're going to come up with our e all raised to the power of 20 iota all over 3. This is equal to minus 1 all over 2 plus the square root of 3 all over 2 iota. So in other words, if we bring our original expression, so we cannot say that therefore our bracket open 1 plus the square root of 3 iota all over 1 minus the square root of 3 iota all raised to the power of 10 is equal to our minus 1 all over 2 plus the square root of 3 all over 2 iota. So this is the simplification. Again, if you want me to break down this expression we have here, how this expression leads to this expression and this leads to this expression, drop it in the comment section and I will make a video on that. So this brings us to the end of this math simplification or evaluation. If you learned something from this, just give this video a thumbs up, and you have a better way of simplifying this, then drop it in the comment section so that OnlineMaths TV can equally learn from you. Thank you for being there all the time. Bye. Until we see you in our next class, keep winning.